A very good evening, and I warmly welcome you all for the WIE Professional Activities First Technical Talks hands-on session for the year 2023 on how to build a P2P energy trading platform in Polygon, organized by the WIE Sri Lanka section with the collaboration of IEEE Computer Society, Sri Lanka Chapter, and WIE Power and Engineering Society, Sri Lanka Chapter. I'm Prabhani Liyanage, Professional Activities Chair, WIE Sri Lanka Section, and Women in Computing Chair, Computer Society Sri Lanka Chapter. We warmly welcome our resource person today, Mr. Anchana Jayavira, a well-known expert in blockchain. So before moving to the session, I would like to give a brief introduction of our resource person, Mr. Anchana Jayavira. He obtained 2 master degrees from 2 recognized universities. One is from University of Robert Gordon in Big Data Analytics from 2017 to 2020, and Master of Science in Project Management from Keele University in 2016. Currently, he is working as a blockchain architect in Epic Tenet, Australia. He was the head of engineering in Electrify, Singapore from March 2019 to December 2021. And he was a senior research and development engineer, blockchain in a talk from April 2018 to June 2018. He's an experienced technology professional with over 15 years of expertise in software engineering, specializing in smart contract and decentralized application development for government, enterprise, and public blockchain project worldwide more than 5 years. So he's recognized in mainstream media and invited frequently to present at blockchain conferences and webinars. So Mr. Anchana conducted blockchain workshops with esteemed universities and featured speaker at inaugural Sri Lankan Blockchain Summit in 2020. Today, the Q&A session will be moderated by Ms. Charitri Apa, who is a lecturer at the Department of Electronic Engineering, Faculty of Engineering, University of Sri Jawadanapura. She obtained her bachelor's from electrical engineering from University of Moratuwa in 2016 and MSc in electrical and computer engineering from University of Manitoba, Canada, 2018, and is currently reading for the PhD in related field, electronic engineering from University of Sri Jawadanapura. So I would now invite Mr. Anchana to deliver his presentation, which will be followed by the Q&A moderated by Ms. Charitri. Over to you, Anchana.
Thanks, Dr. Prabhani. So, hi guys, good evening. So, for further ado, let's move to our session. Let me share my screen so you can see the presentation. I think the screen sharing has disabled, Dr. Prabhani.
It's enabled now.
So,
yeah.
Okay, done. So let me share my browser. Okay. I believe you can see my screen. So, so we'll move forward. So thank you, Dr. Prabhani, and thank you for giving me the opportunity to present on how to build a P2P trading platform in Polygon. So a little about myself. Dr. Prabhani gave everything. I just want to give a bullet from. So I have 15+ years of experience in software engineering and web development. So 5+ years in smart contract and decentralized application development. So work for the government, public, and private projects. So people who are interested about the blockchain knows who this guy is behind me. So he's Vitalik Buterin. So he's the person who developed the Ethereum blockchain. So I met him in 2019 in Australia. So today agenda is actually this. So we are going to give a like 5 minutes introduction to blockchain. I don't want to spend a lot of time there. What is a blockchain is all about and so on, because people who participate for this session already know that what is blockchain is, but I just want to touch a little bit because there are a couple of theoretical aspects I want you to explain. The second one is we are explaining about what is Solidity and its role in the smart contract development. Then we are going for the use cases for blockchain in energy industry. What are the existing P2P energy trading platform? And we are going to have like 20 to 25 minutes of crash course of Solidity. So if you already know about the JavaScript or Python, that won't be that much difficult to learn about, but I will try my best to make it super simple for you guys. Then we are going to build the peer-to-peer energy trading platform in Remix. So Remix is an online IDE, which is we are using for professional development as well to test out our smart contracts so on, and the conclusion and future works and question. So within this agenda, there are like 3 question times. So you guys can write down or ask, and I think Mr. Director will help you to moderate it for me. So let's go for the 5 minutes introduction to blockchain. So what is blockchain? Blockchain is a distributed ledger technology that is shared among a network of computers, allowing for a more decentralized and secure way of recording and managing data. So what is distributed ledger technology? What is decentralized? What is secure way of recording? These are the important aspect of if you want to know about what is blockchain is. So distributed ledger technology is actually the umbrella of a couple of other different methodologies as well. So we have something called directed acyclic graph, blockchain, and hybrid in others. So all the things are not blockchain. Most of these are belongs to the sorry. Most of the things are belongs to the distributed ledger technology, but blockchain is a little bit specific. So in this slide, what the more decentralized way means, imagine you have a set of computers, let's say the network of computers, and you want to play a LAN game. So that's the example I just want to give. So within this LAN network, you can play games and you can play with each other. So consider the distributed ledger technology is a set of computers. You have some program running and it's connected over the internet and you are communicating the data with each other. So what is the decentralized way and the secure? Decentralized way is there are 2 ways of recording the data. One is centralized, another one is distributed. So centralized ledger is something like a single entity. Let's say if it's a, let's take a bank, for example. If all the bank records are actually stored in one central server. But distributed ledger is that all these bank data are stored in several different computers. So this is the distributed. But our keyword here is actually decentralized. That's why I have underlined here. So what is decentralized is, so if you put the centralized and distributed for a picture, so this is how it's going to look like. If this is a single node of a computer or single user is going to access data from one point. If it's distributed, this user can access data from any other place, any other computer, not coming to the same place. So what is decentralized then? Decentralized system is a subset of distributed system, means subset of this image. And decentralized means there is no single point where the decision is made. So I will go back to the same example which I get from the bank. So if you withdraw in the money from the bank, it will record in one place. Let's say if the centralized server is not stored in if the centralized server is stored in a different places, it actually has to record the data in these several computers. Then imagine if it's decentralized, there is a way to communicate this data, how the communication should happen. So distributed ledger, it can be centralized or decentralized. This is what I want to touch down in this 5 minutes introduction to blockchain, because the distributed ledger, especially when you're working in a government or corporate blockchain project, they doesn't want to put this data in a decentralized ledger. They want to have kind of a centralized ledger. So blockchain can be either decentralized or centralized. Then blockchain is a way to implement the distributed ledger. So the keywords here are: distributed ledger is not a blockchain. Blockchain is a type of the distributed ledger. This is the difference. So, but all the distributed ledgers are necessarily employ blockchains. For example, in this graph, you can see that there's something called directed acyclic graph. So there's a distributed ledger technology called hash graph. So it is not a blockchain, but it's actually a DAG. So in your after this session or during the session, maybe you can search and see what is the difference between the hash graph and Ethereum, or hash graph or the blockchain. So then consolidating every information into a graphical aspect, this is what the centralized network means. This is what is a distributed ledger means. And this is what decentralized network looks like. So in this image, why I put this image is, you can see that these red color dots are actually anonymous. That means we don't know who are the actual users in this distributed ledger. But in this blue color dot one, we know actually who are the users are. For example, let's say if you want to do a blockchain project for the government should know who are the users in this network. For example, let's say we are developing a blockchain network for all the universities in Sri Lanka. So this distributed network should know what are the universities in this network. It's not pure decentralized, but still it can work in several different ways. So I put this slide again. What is blockchain again? So in a simplest terms, it's a digital ledger where every transaction is saved in an entity called block with a hashing mechanism. So it's linked and secured using cryptography, which can record transaction efficiently in a verifiable and permanent way. So one of the things in the blockchain is you cannot edit the data, you cannot delete the data, you can only add the data. So when you add in the data, there is a method of adding data into the blockchain, which we call hashing mechanism, using cryptographic way. And that's how the data is going to store in the blockchain. So why blockchain? Because blockchain is secure by design. Because of this element, you can't edit the data, you can't delete the data, you can only insert data. So it's super difficult to hack a blockchain and change the data. Then the blockchain eliminates risk by data stored or held centrally. So let's say for example, if the central bank had flood or something, the data will be wiped out. But in for the context. But if you have a decentralized network or distributed network, the same set of data will store in another computer or another place where you can actually retrieve the data. So it's not stored in one place, it's distributed. So this makes it suitable for blockchain to record events, transaction processing, voting, food traceability, identity management, etc., etc. So there are a lot of use cases you can think of. So a couple of years ago, this whole blockchain thing is limited to certain subjects only. But after 2021, 2022, you come up with any idea, there is a way that you can apply blockchain. So aside from this record events, transaction processing, voting, etc. So little bit history. The origin, actually the blockchain, the concept of the blockchain is actually came in 1991, more than 20-30 years ago. So a group of researchers wanted to timestamp digital documents. Means that if you create a digital document, they are recording the time and nobody can backdate or tamper them. So this is where the start of the blockchain happened. Then in 2008, October, there's a research paper called Bitcoin, a peer-to-peer electronic cash system, released by a person organization called Satoshi Nakamoto, because till this date, we don't know whether Satoshi Nakamoto is a company or a person or someone. So in blockchain world, in crypto world, we are called them anon, means anonymous. So this name is simply there's no person exists like Satoshi Nakamoto. So we don't know who actually introduced it. But this research paper is actually got a lot of traction, and then couple of developers got together, and in January 29, the Bitcoin network went live. So this is where the official start of the blockchain technology happened. Then the Bitcoin network is focused on financial transaction only. So in 2013 December, the Vitalik Buterin, the guy who was in that picture, at the age of 16, wrote a paper called the Ultimate Smart Contract and Decentralized Application Platform at the age of 16, and he published it. So the main difference between the Bitcoin and Ethereum at that time was Bitcoin can only do the financial transaction, means you can send money to one wallet to another wallet. That's the only thing you can do. But Vitalik thought, okay, it should not be the way like that. We should be able to program it. We should be able to do whatever the thing we want to do. So he released this research paper in 2013. Then 6 different people got together and build a system called Ethereum blockchain. And in 2015, July, it went live. So this is the simplest origin story of the blockchain. And for the presentation purposes, this is how the blockchain records data. So in the first block, you will put the data and you will have a hash. Then when we insert the record for the second block, you will get this hash and insert it with the data you want to insert and create another hash. Likewise, this is like a block. It's going one by one by one. So that's why the data is impossible to edit, because let's say instead of Natalia, I want to put like, for example, let's say another name, John Smith. So this hash is going to change because this name is Natalia and we want to change this as John Smith, and the hash going to generate from this data plus the cryptography is going to be different. So imagine if one place could change, all other blocks are going to be invalid. So that's why blockchain is a little bit impossible to hack. What are the potential benefits of blockchain? So we can reduce the transaction cost. This is like 80%, around 90% is true, but 10% is wrong, even though I put it in the as for the slide, because let's say if the network is congested, sometimes the transaction cost is a little bit high. It's increased transparency because all transactions are public There's no private transaction. So you can see what happened between John and Bob, basically. So whatever the transaction happened, you can go to the blockchain ledger, insert their wallet address, and can track, okay, what happened in this case. So it's increased security in the sense like no middleman, and everything is, you can automate it. So it doesn't have any, it doesn't have in the sense like if you program it correctly, the smart contract, there is no way of hacking the data or anything. So increase the automation by smart contract is the same thing as a security one. So we can automate a lot of things. For example, in our case, P2P Energy Trading, we can automate this transaction, go record this data, store the data, give some data for the consumer, prosumer, and so on. So we can automate those functions. Then increase participation by new more actors via decentralization. So imagine if you want to join for a blockchain network like Polygon or Ethereum, you can actually have your own cloud platform or your own NUC system, the small computer, download the blockchain ledger and participate for the network. So while participating, they are paying some sort of money. So how the smart contract works? So smart contract is, even though the word is a little bit interesting, is like a tiny computer program. You just have to write simple set of instruction, you compile it, and you run it. So this is so common from the Pascal basic to Pascal to C++, Java, JavaScript, anything. So we just have to compile and run the program. So it's a super tiny computer program. That's what smart contract means. So we are writing the instruction about what we have to carry out between the transaction. Say in simple words, we are writing the logic, the smart contract. That's the only thing we are doing. So when you learn in Java in the universities, you are saying, okay, if you garbage in, garbage out. So if you put wrong data, it will give the wrong output. In similar case, in the smart contract as well, if you didn't write the smart contract logic properly, you might get able to hack by someone else, or you are not inserting the record properly. So blockchain cannot delete the data, so you just have to test and test and test before you deploy it into the main blockchain network, the public blockchain network. So a little bit of the history of the smart contract. So smart contract is actually introduced by someone called Nick Szabo in 1997. If you remember previously, the blockchain is the blockchain concept came on 1991, but the smart contract came on 1997. So there are some years of gap between that. So it's an ordinary contract, means it's an ordinary computer program. Only difference is it's digital and it can record something. That's the only thing. So in other words, smart contract is a tiny computer program which is stored inside the block in blockchain. So when we store the smart contract, it's always stored inside the block. So it's immutable and distributed. Immutable in the sense like once you deploy the smart contract, you can't change any of the logic there, and it's distributed. It's going for all the network. So it's not stored in one computer. It's going for all the network in the blockchain itself. Then the smart contract helps you to exchange money, property, shares, anything if the value transparent, conflict way while avoiding the services of a middleman. So why we write in a smart contract? Instead of the logic, you can actually execute in a very automate and transparent way. So there's no need to have a middleman when you're executing the transaction. So it's not only for the exchange money, whatever the possible way you want to think of. Let's say if the self-driving vehicles, if you want to have, if you have a business use case there to use smart contract, you can do it. So there's no difference. So why smart contracts are awesome? It's because of the autonomy. That means you can automate it. You can trust the smart contract because the logic itself is transparent, and you can store in the blockchain, and instance are created because the same program will be copied for the networks. That's why it's called backup. So let's say my own node, my own computer went down. Doesn't matter. I can access that same smart contract from a different computer. And because there's no middleman, there's no extra payments. You only have to pay something called gas cost. Think like if you want to drive a vehicle, you have to put a fuel. So this fuel is working as the to betterment of the network. So if you want to store the data, you just have to fuel the chain. So that's what it's called, gas fee. So this is a little bit different when it's come to the private or private blockchains, because in private blockchain there's nothing called gas, so it's completely free. And accuracy, if you write the smart contract properly, and there's no way that will go wrong. So only difference is that if you put garbage in, it will give garbage out. So it's human error. So there's nothing that smart contract will change your code inside. Cool. So now I'm going for, sorry, it took around 20 minutes, even though it's called 5 minutes. So I'm now going to talk about the solidity and the role in the smart contract development. Knowing that all of you guys have some sort of understanding about blockchain, so I will straight away go to the explain about the solidity. So after this one, we kind of have a question session. So if anybody have questions, feel free to put into the box so I can answer whatever the question you have. So solidity is the smart contract language using in Ethereum virtual machine based blockchain. So I'll explain it in the next couple of slides. So the Solidity is a high level programming language using for the writing smart contract on EVM based blockchain. So what is this EVM based blockchain, sir? It's called EVM, stand for Ethereum virtual machine. Just like when you want to run the Java program, you are having something called JVM, Java Virtual Machines. Likewise, to run the Solidity, you need to have the Ethereum-based network. To run the Ethereum-based network, we have something called Ethereum Virtual Machine. So EVM-based blockchain is not only Ethereum, Polygon is EVM-based, Binance is EVM-based, Optimism is EVM-based. There, even the Hashgraph is not EVM-based, but we can deploy the smart contracts in the Hashgraph. So there are around 10 to 12 different EVM-based blockchains now, but when we start, it's only Ethereum. So that's why we call it EVM-based blockchain. So it is statically typed, mean that it's a variable types must be declared before they can be used. Very similar to Python. If you didn't declare the variable, simply you can't execute it because the computer program doesn't know that this variable exists. So Solid support features such as inheritance, libraries, and user-defined types. We are going to use these user-defined types in our hands-on session. Libraries means you, like in a C++ program, you can bring a couple of C++ libraries and execute it. Then in the inheritance, we can actually use the same code again and again, and we can have something somewhat similar to object-oriented concept and execute the smart contract. So it's an object-oriented language, allowing developers to define classes and create objects from them. Even though I say it's object-oriented language, the way we define the classes are a little bit different because we are not using any name called class to write classes in Solidity. We are just writing a contract. So contract are like the class. So Solidity code is compiled into bytecode and executed on the Ethereum virtual machine. So bytecode means, if I put in a very simplest terms, computer doesn't understand what is the logic we are writing, because we are writing either it's in English or something. So then we have to convert this into the zeros and ones, which is the bytecode. So this is the simplest explanation I can give. So after that, after we convert to the bytecode, only we can execute it in the in the blockchain. So that's why we have to compile the code first and run on the Ethereum virtual machine. Then Solidity has syntax similar to JavaScript and C++, making it familiar for many developers. Because let's say if you learn a language super different, the popularity or the way of learning the language will be difficult. For example, let's say, for example, Rust. There's a language called Rust. It's super difficult to learn if you are not familiarized with at least around C++ or Go or something. So likewise, when Dr. Gavin Wood developed the Solidity language, so he thought, okay, this should be very simple and it should be easy to understand by all the existing developers. That's why he make it very similar to JavaScript and C++. So history of Solidity. So it's proposed in 2014 August by Dr. Gavin Wood. He's one of the co-founders of Ethereum. So he's having a different blockchain protocol called Polkadot now, but even in the Polkadot, he's using Solidity as a smart contract language because it's the best smart contract language available at this moment. So the first version is released around August 2015. At that time, we can only record like 32 bytes of data only. We cannot record more than that. So it was super simple programming language. But then open source developers get together and introduce it. So I start to code from 0.4.14. That's the version I start smart contract development. Now the version is actually 0.8.27 or something. So it's still not the version 1 even, it's still 0.x. So then you understand that how difficult, or how, I don't want to use the word slow, the progress, because even it's not came to version 1 yet, there are billions and $trillions of transaction happening even right now. So it's the most matured smart contract language up to now. And even though it's the version is not become even 1, there are tons of things you can still do it. So Dr. Gavin Wood thought, yes, he needs a language that was easy to use, and that's which allowed to complex programming construct. So what he really wants to do is he wants to write some functions, convert it to bytecode, run on top of the blockchain. So this is what he wanted to do, and that's why he made Solid language as simple as possible. So the key features of the Solidity we spoke in previous slide as well. So it's having the object-oriented principle. It's strongly typed, means like variable must be declared with a specific data type before you can use. Otherwise, it will give an error for you. So it's contract oriented in the sense like you cannot use Solidity for do any other things other than writing smart contract development. You can't use Solidity for have your local program running or something. You can't use that. Then it's super security focused, meaning it has the it has built-in features that it's easy to write. For example, let's say if you write a very large integer number, and if that data type is mismatched, it will give from the compiler and give an error. Okay, you can't store this number in this data type. So that's why it's super security focused. So imagine if you, for example, let's say if you want to send only 100,000 LKR in the smart contract. So that's the maximum number you can send. You are defining, okay, the maximum number you can send is 100,000 LKR in the smart contract. And for that, you have to use the proper variable type. So that's why it's security focused. Then you don't have to worry about, okay, what will happen if I enter 100,001. So for example, so it will not execute because you are already put the variable type as, okay, this is the maximum number or maximum bytes we can have it inside the variable. Then integration with Ethereum virtual machine, as I said before, so there are like 10 to 15 different EVM based blockchains now, including Ethereum, Polygon, Polkadot, Optimism, likewise, Binance Chain as well. So if you know one language, if you know Solidity, that means automatically you know how to deploy smart contracts in several different chains. So that's the beauty of learning Solidity and the beauty of integrating with the Ethereum virtual machine. So we are coming to the end of this session before we go into the questions. So Solidity syntax and structure. So Solidity program looks like this. You can see that there's something called Pragma Solidity, and there is a 0.8.4 version, and there is a license identifier, and something like the JavaScript keywords called contract, struct. There's an array type of thing, and there's a modifier address. So this is how the simple smart contract looks like. For example, this smart contract is be like you can add people and get the count of how many people are there. So that's a simple smart contract. So if we compare this program, the same logic, into JavaScript, this is the Solidity contract, which I have the number. Then I have a function called set number, and I have another function called get number. So forget about all the keywords. The logic behind this is you have a variable called my number, and you have a function to set a number to this variable, and you have another read function to get what is the number set by here. So this is a Solidity code, and this is the same thing if you write it in JavaScript. So instead of let in the JavaScript variable writing, you have something called uint256 here. Then you have the function set number, and you are passing a number, and you are assigning that number to my number variable. So it's having the same thing, set number, you are passing a number, and set that my number, set that number to my number variable. And you have a get number, and you are returning my number variable, and you are returning my number variable with the get number function. So forget about these public key returns and what so on. We are going to discuss it about later, but it's very similar to JavaScript. So you understand it's not super difficult to learn. Then when we compare the Solidity with Python, because I heard that for this lecture, there are people participated here know about the Python a little bit. So I thought, okay, we'll put what's the comparison between Solidity versus Python. So this contract, again, the same thing. You have a variable called my number, you have a set number function and get number function. In Python, you can write like this. So you put the my number as 0, you can put the set number using this, and you equal it, and the get number is returning. So only the syntax are different, but the logic wise, it's super similar to JavaScript, Python, C++. Likewise, so whatever the program you want to compile and run, it's very similar to Solidity. So that's the first part of it in our session. So if you have some questions, I am ready to answer. So I've seen a couple of questions are here as well. So Tashin Ranasingh asks, is there any advantage that getting knowledge of financial sector qualification in order to work with blockchain technology? The answer for that is yes and no. So I'm not coming from a financial background, but when you want to do some programming stuff, anyway, what you want to think about is you want to know about the logic. So let's say if A happen, what will happen for the B? If B happen, what will happen for the C likewise? So uh, that's why it's no. Then the yes part is actually in blockchain world, there's something called decentralized exchange. We call it DEX, DEX. So for the decentralized exchange, what will happen is every financial method you are using in bank plus some more happening in the blockchain world. So if you are super interested about the financial part of the blockchain and having the financial sector qualification or knowledge is going to work for sure. Because let's say if I tell you something like, okay, I want to know the yield of my deposit. So then you will think about, okay, what is the meaning of yield? So yield is another word for what is how much percentage of money I can get if I deposit 100,000 rupees in the bank. So it's very similar to interest. So yield equal interest. So if you don't know, so in the financial sector, people, they know what is a yield is. So get to know about the financial terms and how it works could be beneficial for sure. But if you ask me whether do I want to have a qualification, whether like what are the any double AT or anything, it's up to you. So if you love programming and financial, maybe it's better, but it's not a must. Then Gayatri asked about, can blockchain be implemented in MATLAB? As far as I know, you can't. Reason is the way we write in the smart contracts are a little bit different. MATLAB has a different set of conditions, so that's why you can't implement a blockchain in the MATLAB. Sausri Sampath. So I know this person. Hi, Sausri. So what are the prerequisites like Remix as for ID of personality? Actually none. So Remix is an online IDE. You don't have to install anything to run smart contract. You just simply go to the Remix window and type the smart contract. So any other question, Ms. Charitri?
Well, I wanted to ask one question from you.
Yeah.
Now blockchain is used to like do the transformation from centralized to decentralization. And what are the challenges that you have come across which blockchain also cannot solve? Blockchain also cannot help in this transformation. Any unsolved challenges?
Yes. So I was able to do a blockchain project for Australian government called Australian Tax Organization. We call it ATO. So before we do this blockchain project for them, we have to analyze like 25 different blockchain protocols. The reason why we wanted to do that is they had the requirement saying they want to send transaction privately. So the blockchain is not a place where you can send the transaction privately, because everything is public. You can see everything. Even in the private blockchain, it's a little bit difficult to make that transaction private. So let's say between, let's say, Gayatri, Tashin, and myself, I am sending a message for Tashin saying, okay, Tashin, hi, how are you? Then actually Gayatri can see, okay, Anjan has sent a message for Tashin saying, hi, how are you? So their requirement was, I want to communicate between Tashin and myself, but Gayatri should not see that. So can it do it in blockchain? It's yes. There's one protocol you can actually do it. You can send private transaction. So if I send message for Tashin saying hi Tashin, then Gayatri only can see, okay, Anjana sent something for Tashin, but she can't see what exactly which I sent. So still the transaction is public, but the content of the transaction is private. So this is the one of the biggest challenge I had in my career, because when you have a consortium like a government, let's say you have the financial department, you have the security department, so and so and so. There are a couple of departments get together, and if you are sending some sensitive information between the security and treasury, then some public department cannot see that. So it was super difficult to achieve, but we managed to do it somehow. So there's one blockchain protocol called Hyperledger Besu. They are allowing the private transaction. So that's the biggest challenge I had in my career.
Okay, thank you. Any other questions from the audience?
So guys, there are no bad
There's
questions or
there's
right
one,
questions.
I think, suggestion. So I think the answer, like a follow-up, can't you use zero knowledge proof to achieve private transactions?
Okay, zero knowledge proof is a different concept. Zero knowledge proof actually came like last couple of months into the picture in the practical way. So why it cannot use? So zero knowledge proof has two types of thing: optimistic rollups and another thing I can't remember the name from out of the picture. So even though zero knowledge proof is saying that, okay, we just have to check, okay, let's say if you want to go to a club, and if there's a rule saying that, okay, for this club, the entrance is only 18 plus people, we don't have to show the identity, we just have to verify from a third party saying that, okay, this person is 18 plus or not. So we are saying for a third party person to check and tell me whether this person, let's say Indonil, is more than 18 plus or not. So that's the simple explanation of zero knowledge proof. So what will happen in zero knowledge proof is still there is a 1% chance you can see what is the content of the message. So you check in zero knowledge proof, they never said it's 100%. They only said it's 99%. So there's a 1% chance to know what's going on. And that's why zero knowledge proof cannot use it for the private transaction. You can only tell and verify, okay, this is what happened. So if you want to check the private transaction, so Hashgraph has a different mechanism as well to do the private transaction, but in blockchain, in distributed ledger technology, where private transactions are somewhat impossible to do, but different protocols are using different methods. So zero knowledge proof also using something like that. So based on the zero knowledge proof, there is a way that if you want to challenge that decision, let's say that Indonesian is not 18 plus. So if I know that Indonesian is not 18 plus, I can actually challenge for that transaction and say, I personally know Indonesian, he's just 16 years old guy, and I want to revert the transaction. So there is a challenge period. So if I won the challenge, I can revert the transaction. So it's not really private transaction in that case. I can challenge it. So that's the difference. I think I answered that question properly. Any other questions, guys?
Move on to the next session now.
So I want to tell, so there are no right or wrong questions. So when I learned about blockchain, I asked so many stupid questions from everybody I met because I want to learn properly. So if you have anything, don't worry about that. Is this question is right or wrong? You just ask right away. For example, this zero knowledge proof question is very good question. Everybody thinks that it's a private transaction method, but it's not. It's really not. So it's a method of achieving the consensus and getting the decision about whether we are going to do this transaction or not. Cool. In that case, assuming that there's no more questions regarding the blockchain and solidity, I want to touch the use cases for the blockchain in energy industry. Okay, there's one other question. Saja Rupan, how to manage communication between nodes? There are a couple of ways. So in Ethereum, at least, we are having something called gossip protocol. What happened is that I don't know whether you know about the PubSub method. PubSub method is like you are sending a notification saying, okay, I got a message. Somebody will go and grab that message and execute it. So that's how the PubSub method works. In the blockchain world, in the nodes, you want to run a kind of a scheduler node, which is trying to connect to the other nodes, and the EVM software is take care in all the communication for us. So it's not really manual thing to do. We just have to up a node. We just have to install the blockchain software. In Ethereum, it's just we have to install some Go packages in the Ethereum, and you download the ledger. There are two ways of downloading the ledger. You can download the full ledger, which is around 4 terabyte. Last I checked, then you can actually download the header only of the blockchain. Means like you are getting the hashes only and not really the data. So based on these two methods, let's say if you download the full blockchain, which is the 4 TB version, when the last time I checked, it will take you around nearly 1.5 months, 2 months to download everything because it's super slow. So this session is recording. I can't use the exact word, but let's say if you're doing the peer-to-peer downloading, there's a different word for that. I think you guys can understand yourself. So when you download something to peer-to-peer document download software, you can see there are seeders connected to the network and download. If you have more seeders, you can download it fast. If you have less seeders, you can download little. So imagine 4 terabyte of data is downloaded from different parts of the world and different computers in a different speeds. It's going to take some time. So one time I did this 4 TB blockchain download. It took me around 18 days because I used a fast SSD, so I could do it. But if you use normal SSD, or if you use a cloud hard disk like Amazon EBS or something, it will take a lot of time. So the answer to the question is that they are using something called gossip protocol. So based on the gossip protocol, they are doing the communication. So in ourselves, you can go and read about the gossip protocol. It's super interesting communication method. I'm not going into more technical way to explain it, but that's how the nodes are going to communicate. So Sasri asked another question. .NET frameworks and blockchain are combined, different from Ethereum. They need to separate blockchain network. So when you have open source software, the beauty of it is people who are passionate about this technology will write software libraries to passionate about the people, write some software libraries to communicate with the blockchain. So the main language or main language we are using to communicate with blockchain is actually called Go. It's not Solidity. Solidity is using for the smart contract development. But if you want to write data into the blockchain straight away, you can actually use Go, and you can use Python, and you can use Java. So as well, not for the smart contract, but communicate with the blockchain. So again, for the .NET, so for at least for the Ethereum, there's a solution from .NET as well. There's a solution from .NET for the Hashgraph too. So if you know about the C# or the .NET framework, if your blockchain protocol supporting that, you can actually write some smart contracts and execute it. So in the Solidity one, I told that even you write the smart contract in Solidity, it's actually convert into a bytecode. So whatever the language they are using, you have to convert into the bytecode and execute in the EVM. So it's not really a separate blockchain network. It's the same blockchain network. Only difference is that the language you are using to write the smart contract will be different. So it's like, let's say if you want to go from Borella to Kiribati, you can either use 154 bus or can you have a car. So if you go 154 bus, it will take a lot of time. If you have a car, you can go fast. So it's like the method of transport is actually method of the way whether you want to write the smart contract language or not. But most of the time, these languages are open source, and .NET is having pros and cons, but it's possible to write. So that's the answer. Cool. So use cases for blockchain in energy industry. So this is kind of the course session in today, because we are going to build peer-to-peer energy trading system in a little while. So you want to understand what are the use cases and how the blockchain is using in the energy industry. So global market insight is kind of the research people. They are saying that blockchain technology is in energy market to hit 3 billion by 2025. Means like it's a massive opportunity in the energy industry to use blockchain technology, because it's a lot of people are not touching blockchain into the energy. The reason is energy industry is a super difficult industry to introduce some new technologies the way it happened. So, but if you, let's say if you start in something related to energy from the scratch, then if the blockchain technology is going to solve your business use case, then the blockchain technology is super good, and it has a massive market for hit this 3 billion opportunity by 2025. So this snapshot is actually taken from 2018 September, but let me, I think I have okay, it's from front. So in 2018, there are 189 companies working in blockchain in energy alone. So 189 companies, and 71 projects are focused on blockchain in energy, and they invest around 466 million for the blockchain in power. And out of that 71 projects, 50% of projects build on Ethereum blockchain because of this smart contract language, and it's easy to execute. So this is taken from magazine called IRENA. It's called International Renewable Energy something. I can't remember. So they have something called Blockchain Innovation Landscape Brief. If you search this term, you will be able to download that report. So this is the snapshot taken from the 2018. So what is the role of blockchain in power sector? So the energy sector is a very centralized market structure, and they are having a super regulatory environment which makes a highly suitable sector for application for blockchain technology. You can see some of the keywords are actually here: centralized, regulatory environment, and that's why you need a technology like blockchain to do some changes in energy industry. Then electrons can trade it instantaneously with minimum transaction fees in a decentralized network, while payments can be processed simultaneously as well. So this is where there's Shane's question comes into the picture. Can we marry this financial plus the energy trading together? You obviously can. Do I need to have a kind of qualification? You can have. It's not a must, but if you have something, it's good. Then consumers are becoming active participants in the market, able to buy and sell energy without involving a trusted authority or intermediary. For example, let's say I hope that you all know about the term microgrid. So microgrid is a place that you are not connecting in the grid itself, is not connected into the main grid. You are generating your own power from the solar or hydro or something. So to do that, you actually don't need intermediary at all. So you can do it by yourself. So then there's another part called smart meter solutions. Let's say that if you want to see, okay, how much energy I have consumed, how much energy I have produced, how we going to measure it. That's where the smart meter solutions comes into the picture. So if you install a smart meter, you can actually track how many energy you have consumed or how many energy you have produced. So then we have the carbon reduction incentives. Green certificates can be determined and instantly. So this green certificate is another thing that blockchain technology can use very um, very nice and effective way. Um, you might heard about the news saying, okay, Apple is saying we are 100% green. The Google is saying we are 125% green. Then the Microsoft is saying that our data centers are 100% running by renewable energy. So likewise, these are the news headlines you might heard about it. So how they actually going to achieve this 100% or 125%, or how they are going to assign this green energy into their data centers? That's where the something called renewable energy certificates, or the green certificates we are saying, is comes into the picture. To build the renewable energy certificate, blockchain is a super good technology and very transparent way you can get it done. And personally, my previous company worked on a project like that. Then personally, there are around 5 to 6 different companies actually work on the green energy certificate using blockchain, because it's very transparent and it's highly regulated, and it's need a change. So blockchain is a good technology to use in the green certificate. So the company called Consensus. So the Luban is one of the co-founders of Ethereum, and he is running the company called Consensus. In one of their reports says, of the many use cases for blockchain, energy and sustainability are often less recognized. So let's say if you get like 1,000 blockchain projects, only around 10 projects are related to energy. Reason is mainly because of the regulatory environment and the way the energy industry has boomed after the 1970s. It has some changes difficult to happen. So that's why even the blockchain is a novel technology. Some of the use cases when you try to apply for the energy industry, it takes time. It can be done, but it takes time. So key applications in energy are actually these 5 things. First one is the peer-to-peer energy trading, which is we are trying to do it today. The second one is the renewable energy certificates. The third one is the grid management and system operation. let's say if you want to balance the grid, if you have a microgrid, and if the lot of energy sources are connected to the grid, how are you going to balance it? So can we use the blockchain technology to do that? Yeah, obviously you can. Then electric vehicles, IoT and others. So if you ask me how we can use blockchain technology for EVs, so electric vehicles, there's something called uh, EV to grid. We called it vehicle to grid, V to G, means like you can charge your electric vehicle battery using 100% renewable energy using peer-to-peer energy trading, and you can sell your excess battery energy back to the grid using an EV. So one of the France company did that, this vehicle to grid operation. So how they how they demonstrated that was, let's say you have to go from let's say Bambalapitiya to Bambalapitiya to Kollupitiya, let's say, for example. That's where your house is. Bambalapitiya is where your campus is, something like that. And you only need like 5 kilowatt hour worth of energy. So that's the only energy you need, and you know that there's no traffic going to happen, and you are going straight home, and you are not going anywhere else. So you only need 5 kilowatt worth energy in your to go from Bumblebee to Columbia. But in your EV battery, you have, let's say, 20 kilowatt hour energy, but you only need 5, and you know after you go home, you can recharge your vehicle. If there is a energy requirement for 15 kilowatt worth hour energy at that time, you can sell this excess energy of 15 kilowatt hour to the grid using electric vehicles. So YouTube it, there's a super good presentation on how they did it, how that company did the vehicle to grid transaction, and that's how these electric vehicles comes into the picture. So IoT wise, it's purely for the smart meters, not only for the smart meters, but you can do a lot of things with IoT devices. For example, I work with a company in Australia here, so they to calibrate their IoT device, what they are asking us to do is go and boil a kettle. So then I asked why we want to go and boil a kettle. So they said that's how they are calibrating their device to measure the energy. So energy is measuring in kilowatt hour basis, but the signals are going in hertz level. So for this device, this IoT device, they could actually measure 100 points hertz, means like 1 of 100 points hertz level energy consumption through this IoT device. So what they did was they measured this when you put when you boil a kettle, your energy consumption goes high in a very hertz level, and they measure it, they put into the AI system and calibrate in the device. Okay, this is how their energy consumption looks like. So that's how that IoT device works. So super interesting. There are even from a module like simple modules like Arduino or anything, you can build this kind of IoT device. It's super easy. When we signed the NDA agreement, they showed us how they actually did it. It's super simple. Public information are the ones which I shared with you guys. They actually using artificial intelligence to calibrate their device, and they are rewriting the firmware based on our energy consumption. So little bit extra information, but I thought it is interesting. So these are the key applications in energy. If you put into a pie chart, you can see that 30%, 36% of energy projects are actually peer-to-peer power trade. 24% are grid management and system operation. There are 11% of EV. Management of renewable energy certificate is another 11%. Financial renewable energy development, 12%. This is for measuring of the, let's say, if you want to use hydro, if you want to use wind, you will get different energy profiles. So it's a different method of pay, and all other energy related projects are around 6%. So if you put those 71 projects into a pie chart like this is how it distributed. So after we speak about energy industry, we are coming to peer-to-peer energy trading. So what is peer-to-peer energy trading? Let's say you have a rooftop solar, for example, and you are generating energy and you use yourself first, and this excess energy you will be able to sell through a platform, and maybe you can sell it for the same price or a lesser price than the grid price. So to explain it a little bit more, we call this solar energy called renewable energy, which is the green energy, and all other energy types are like not renewable energy, we call brown energy. So let's say if you want to have green energy to your house, if there is no method to get it, you can actually do this peer-to-peer energy trading. So this is the simplest explanation of how and what is the peer-to-peer energy trading and how it works. So in the other terms, so it's a decentralized approach for the energy trading, allows consumer to buy and sell excess energy directly into one another. So it's not require a centralized energy provider, which is, let's say, if you have a microgrid. So microgrid transaction, you really don't need to have a centralized energy provider at all. And provide great control of transparency in energy transaction. Let's say that if I'm getting green energy from Sausri, if Sausri is selling for, let's say, I'm selling for ₹1 for 1 kilowatt hour, I know the price. So CEB will not come and say, okay, from 0 to 30 this price, 30 to 60 this price, 60 to 180 this price, likewise. No, because I know that Sausri is going to sell the energy for 1 kilowatt. ₹1 for 1 kilowatt hour. So the pricing is super transparent. Let's say he also bring in a condition saying if you use more than 50 kilowatt hour worth of energy from me, I will give like 20% discount. So let's say then after 50 units of energy, I'm getting for 80 cents per kilowatt hour from Sausri. So that's the transaction could be transparent up to that level. Then the potential of cost savings and increased use of renewable energy resources. Actually, the cost saving is depend on at what price this producer, the energy producer, is selling the energy for. Usually, green energy is expensive everywhere, even though it's generating freely. For example, let's say solar panel. So the energy generated by sun. But when we sell green energy to someone else, either you can sell it for the same price as brown energy, or you can sell it for a lesser price or higher price. So it's purely depend on yourself. So even though this renewable energy, green energy is generating free, the underlying hardware is expensive. So that's the reason for that. For example, let's say for solar panel, earlier before COVID happened and before dollar rate goes higher, for around 300,000, you can have a decent set of solar energy panels. But now it will take around 1 million based on the dollar rate and so on. Let's say if you want to have a wind turbine, it costs a fortune, even though the blade type 1 or the rotate type 1 still costs a fortune. So even though the wind is getting free, but the underlying hardware is super expensive. So that's why the green green energy. If you saw somewhere that green energy is expensive, this is the reason. Even though it's generated freely, the underlying hardware to harness that effort is expensive. Then how peer-to-peer energy trading works? The same example. Let's say if you have a rooftop solar, you want to sell that excess energy through a platform, and you're going to do a paper settlement with the energy trading provider, saying, okay, this is the amount I have sent, this is the amount I have this is the amount I have exported, this is the amount I have consumed, and please pay me. So as simple as that. So even though these words are super big, that's the simplest explanation. So energy consumers generate excess energy from their renewable energy sources. It could be solar panel, it could be wind, it could be hydro. Let's say a person somewhere near to Mahavali, they have their own water turbine to generate energy. And let's say if he's living near a waterfall, so he can actually have a turbine, water turbine, and generate the electricity. So, and he can sell that energy back to the grid. So then the transactions are recorded on the blockchain platform to ensure transparency and security. The keywords here are actually transparency rather than security, because let's say if Indranil wants to, if Indranil say that, okay, I exported 10 kilowatts hour worth of data, but if Gayatri said, okay, no, I only use 8, so there's a disruption. So how we going to check what happened for that, the 2 kilowatt hour worth of energy, what happened for that? So that's where the IoT device comes into the picture. So everybody has IoT device, so you can measure the energy and you can do the settlement through the blockchain. So it's super transparent and easy to execute as well. So smart contract facilitates the automatic execution of the transaction between buyers and sellers. So you can write the smart contract, say, okay, uh, if if the energy transaction happened like this, okay, pay the money from my wallet to this person, likewise. So you can automate it. Pricing can be determined by the market demand and supply for energy, or by set by the producer. So as the example I said, Sausri can sell energy for 1 rupee or 80 cents or 2 rupees. So it's up to him. But in the market like UK, what they have actually called the future market, means like uh, the energy price for tomorrow you can actually see by today. So that's called the future market. And Singapore has a 30 minutes market, means that their energy bill actually calculated every 30 minutes. Unlike Sri Lanka has Sri Lanka actually has hourly rate as well. This is using for the mostly for um, industrial usage, because it's for consumers like home house consumers. They are not getting the energy by 1 hour basis. We are getting mostly monthly basis. But Sri Lanka also have a method that you can get the energy bill 1 hour period of time. It's not super famous among Sri Lankans, but we try to bring my ex-company solution to Sri Lanka. So that's how we found out that they have this 1 hour energy transaction method. Then the peer-to-peer trading can reduce energy costs for the consumers and increase the use of renewable energy sources. It means, let's say Sri Lanka has these power cuts and so on. If we really have a good method of generating renewable energy through wind or hydro or something, then definitely we are not having power cuts at all like last couple of months. But let's say even you have a microgrid level between your household or in your village or town, this is also possible to work as well. So it can reduce the cost and it can increase the renewable energy sources as well. So we don't have to wait until diesel is coming to the Sri Lanka to have the energy. So key components of P2P Energy Trading Platform. So now this session is going to get in a little bit interesting. Reason is you want to have some kind of understanding about what are the components you need to develop the smart contract, and you kind of need to have some kind of logic going behind your head. Okay, these are the information we are going to store in the these are the information we are going to store in the blockchain, and this is how the logic flow goes. So what are the key components of P2P energy trading platforms? Energy trading contracts, that's the first thing. You want to store how many energy consumed and how many energy produced by consumers and producers or prosumers. Payment contracts, if you want to carry out the bill, you want to have a payment contract. Use authentication, before when we onboard in the people to the platform, there should be a method to register the users. Then energy tracking and monitoring. So we are using IoT device to track the energy production and consumption. So there is a way to, there should be a function to track and monitoring this energy transactions and market analysis. So market analysis that it's not super common in Sri Lankan market, but let's say if a market like UK or if a market like Singapore, so hence they are, I'll take the example in Singapore because I know it pretty well. Let's say that you can see what is the demand for the next 30 minutes or next hour based on the platform built by their grid provider. So this is the market analysis. Let's say, so now my time is 10 p.m. Let's say for next 30 minutes, I need like 100 gigawatt hour worth of energy. But from my grid, I only generating around 450 gigawatt hour worth of energy. So I have a lack of 50 gigawatt hour. So where I can bring this 50 gigawatt hour, that could be bringing from the renewable resource like wind or the hydro. Then I connect my, let's say I have a wind farm. I connect that wind farm cable into the grid. Sorry for this term, but that's a super layman term to explain this, what is the market analysis is. Let's say I plug my wind turbine farm into the main grid, then the grid can understand, okay, there is enough energy for the requirement of 500 gigawatt hour worth of energy is available in the grid. So this is how the market analysis is doing. So there are a couple of ways you can do the market analysis. One is actually, so what I explained is actually the grid management. So that's a part of market analytics stream. Then you can say, okay, to give 50 gigawatt hour worth of energy, I need, let's say, $1,000, for example, let's say. So then we are going to a bid mechanism. So this bid mechanism is available even in the Singapore and the UK both, and the Thailand also having a very similar platform for the market analysis. And if the government agrees to pay this $1,000, government can get. So what happens usually is, even though this looks automated, is really not. There's a very complex bidding system going on behind the picture to do this market analysis, especially when it's come to the P2P energy trading. But hope you got the picture of it. And now we are going for the question round number 2. And I got a question from Indranil. Is the P2P energy only related to microgrid? If it can be applied for the regular grids, how does net metering come into the picture? Right. Good question. Unfortunately, there's no simple answer, so I had to explain a little bit more. So the P2P energy trading is not only for the microgrid. So people are thinking that peer-to-peer energy trading can be executed only in microgrids. It's actually not, because you can execute the peer-to-peer energy trading in the whole grid, country-wide grid. So that's where our platform comes into the picture. In Singapore, Electrify has done the world first peer-to-peer energy trading in a country-wide grid. So that's what we did, and we kind of have a patent for that as well. So then if it's come to the regular grids, how the net metering comes into the picture. How the net metering comes into the picture in the sense like you need to have, let's say if you are doing peer-to-peer energy trading, and if your system is smart enough, you should not have any excess energy at all to have the net metering. For example, let's say now I how many people are here in this call? Let's say 20. We have a 20 people. 5 people are producers who are energy generators, and 15 are consumers. We'll get this example. Then if these 15 consumers has enough energy to buy from producers, who are the energy generators, through some kind of algorithm or some kind of game in theory or something, you can actually give all your produced energy, you can distribute all your energy which you have exported between these 15 consumers. It could be percentage wise, it could be some kind of gaming method, this could be some kind of matching algorithm, you name it. So companies are using different methods. For example, Electrify using a patent mechanism. There's a company called Polygon in Australia. They're using a different mechanism. There's a company called WIE Power in Spain. They're using different mechanism. And there are a lot of peer-to-peer energy trading research papers published in even IEEE, a lot, which you can come up with a different trading mechanism. So it's up to you. It's up to your company. So if you manage to distribute all your excess energy between these 15 consumers, that means you don't have any excess energy to get from the net metering. But it's not happening in that way most of the time. Let's say there are some excess energy happen. For example, let's say Indranil is exported 20 kilowatt hour worth of data. He able to sell 15 kilowatt hour worth of energy, and now he have 5 kilowatt hour left. That 5 kilowatt hour only you are going to get from the net metering. So this net metering concept, it's not common for each country. Each country has a different method of paying that net metering system. So for Sri Lanka, they are paying around, I can't remember, 10 to 12 rupees as I remember. But in Singapore, you are getting cents, literally cents. So it's up to you whether how you're going to monetize your energy, whether you can go to the net metering or you can go to the peer-to-peer energy trading. For at least in Singapore context, you can actually sell your sell energy through peer-to-peer energy trading more than the price of the net metering you are getting from. Even in the UK, you can sell your excess energy more than the price you are getting from the net metering. But in case if there's nobody to get your excess energy, unfortunately, you have to get for that 10 rupees or 12 rupees or cents in Singapore, your excess energy. That's how the net metering works. So that just means that utility company government has to change policies and laws to allow peer-to-peer energy trading. Definitely, yes, Sunil. That's why energy industry is super heavy regulated, especially for a country like Australia. Australia always has grid unbalancing because most of the time, all these Australian houses has solar panels. and government is encouraging them to have solar panels. And Australia is a country which is getting like the sun is there like most of the time, unless it's winter, and you're generating energy continuously. So what most people are doing is, if you have a rooftop solar in your house, they're actually purchasing an EV, because the Australian government is giving some kind of subsidized price for if you're buying a electric vehicle. So they are charging the electric vehicle from the solar panel, but the excess energy going back to the grid. And let's say if the grid operator didn't discontinue the energy getting from the traditional producer like the diesel or hydro something, this grid is going to be unbalanced. So in every energy company, grid related energy company in the world, every company, even in Sri Lanka, there is a way to check how much energy is, what is the energy usage of the grid at a given time. You can measure it. So they have a method to measure it. So what Australian is doing is, if they feel like, oh, by their grid management software, okay, the amount of energy in the grid is too much, they actually disconnected from their traditional energy producers and give chance for the solar panel holders or hydro users. So that's why it's super interesting. Plus, you have to be super careful as well. And definitely, at least for Sri Lanka, definitely you have to change the policies when we doing our peer-to-peer energy trading pilot in Singapore. We kind of need to go to the government and say, okay, we are doing this. We are only doing for some certain number of participants only, so the grid is not going to change. There will be a grid balance as on. We just doing a settlement through the blockchain and so on. We just have to explain it. We have to provide like 20 to 30 different page report for them saying, okay, the grid is not going to unbalance. So definitely you need to have some kind of policies has to change. When I explain about the Australia really doesn't have peer-to-peer energy trading mechanism, because from the government law it's prohibited. You can do the peer-to-peer energy trading in the micro grid level, but not in the city level or national level grid. You can't do that. Sorry for the multiple question. Please only if you have time. If A sells energy to B, B will receive that energy through the utility meter, then we will be billed twice. How to avoid it? Very good question. Okay, so to do that, to solve this double spending thing, there's something called contract for difference. We call it CFD. What will happen in the CFD is I can explain up to some extent, but I can't explain super transparent way. Sorry for that, because of the patent pending, and I'm still obliged for my previous company up to 10 years, so I can't reveal any secrets. So how the CFD happen is, you are doing them rather than bill twice, you are actually checking how much energy you got from the grid and how much energy you have consumed. So in a simple means that you need to have 2 meters to check these two. What is your consumption? What is your import? And if you are a producer, let's say if you have a solar panels in your house, you want to have 3 meters. What is your consumption? What is your import from the grid? What is your export? Let's say if you have a rooftop solar, if it's a rainy day, you can't generate energy at all. So you have to get brown energy. So to measure the brown energy, there should be a different meter. So that's why you have 3 meters. So even though I use the word meter, this is actually the same meter, but 3 different registers. In Sri Lankan context, if you if you can see, if there's a rooftop solar panel, they have a very different size meter type, which you can record the import and export both. Then, but in countries like UK, so they have the 1 meter, but inside the 3 registers in the meter, 3 registers means 3 ICs in the meters. You can measure the import, export, and generation separately. So that's how it works. Sorry, I'm getting the UK as example because the father of all electricity meters in the whole world is called Ed Everson. So Ed Everson is the person who actually wrote the electric meter specification for UK households. Hence, it's so good. Like 98% of the countries in the world using Ed Everson's specifications. And I spoke to him personally as well because he's one of the founders in renewable energy certificate specification called IREC, International Renewable Energy Certification Protocol. So Ed Everson is the person who actually developed that specification for the electric meters. So then it's not really built twice. It's measuring the energy, and you are doing you are doing a mathematical calculation. Let's say if you minus your import from the consumption, you are actually getting how much you import from that import from the grid. So that grid could be comes from a producer, or it could be comes from brown energy or the grid operator. So how are we going to measure that? You want to have IoT device in place for that. How going to actually measure it? So that's how all the peer-to-peer energy trading platform doing it. You can go and read it in any peer-to-peer energy trading research papers published in IEEE as well. Because CFD, contract for difference, is a super common term to how to avoid this billing twice methodology, and the way companies doing it is a bit different. So my company did it in a different way, another company is doing it in a different way. Research papers are actually did in super different ways, but very practical ways as well. There's a research paper called peer-to-peer energy trading game theory aspect or something from one of the Malaysian university. It's published in IEEE actually. You can go and read that research paper. They are bringing the game theory concept for do the energy trading. And they are saying, okay, this is how you going to do the contract for difference or the pricing to avoid the double billing. So I hope that answer your question, Indra. Something asking, so it means like load sharing is, it's not really load sharing, but it's simply a tracking of electrons in a paper. So we call it paper settlement. So in physics, you really cannot track electrons because you can't see electrons. That's the honest answer. How we going to track the electrons, or how we going to track the energy, is actually using the IoT devices. So that's the answer. Do we have any other questions?
Sanjan, one follow-up question for what Indranil has asked now. You said there's a contract for difference to like identify how much energy comes from brown energy and how much comes from green energy. Say the green energy comes from 2 different procurements. So how to build that separate? Like how to identify which now if A buy from both B and C, or both of them are giving renewable energy. So how to identify that? Because in terms of not a microgrid, in terms of the national wide grid. So
yeah, national wide grid, Ms. Charitri, it happened is that's where I bring the term the paper settlement. Hence, we cannot really track the electrons. What is the paper settlement doing is at a given time, let's say now it's around 10:20 here. At this 10:20 time, what is the import of the consumer? What is the export of the producer A, and what is the export of producer B? And you kind of need to have a subscription. Without having a subscription, you can't do this. Let's say that if I want to get just like your mobile phone, right? To get a call, you want to either register for Dialog, Mobitel, Hutch, or something, right? So if you register with Dialog, that means you can get calls for the Dialog plus other networks as well, right? I'm trying to explain it very simple way, then you can connect the dots. Then if I know that my contract is with the Dialog, I know that to every outgoing call, I have to pay for the Dialog for my outgoing calls, because my contract is with Dialog itself. But now let's say we are going to get a call for a Mobitel network provider, but that call is going first for the Dialog, and Dialog is connected to the Mobitel, right? But you can't see it. You are thinking like, okay, we are connecting to the Mobitel grid straight away, right? But behind the picture, what will happen is Dialog has to settle this transaction behind the curtain, saying, okay, Mr. Mobitel, I have a consumer who got a call for your network, and he or she spoke around 30 minutes, and this is the cost, right? So then Mobitel saying, okay, your guy called my network 30 minutes. I will charge you 20 rupees, for example, let's say, right? Then Dialog, you say, okay, thank you. Here's your 20 rupees. Then Dialog comes to you and say, okay, Mr. Charitri, your 30 minutes call cost 30 rupees for me. Means there's a 10 rupees profit for the Dialog, right? Likewise, like this example, I can't go into the exact scenario, but this is how it works. This is how the contract for difference basically works. Behind the curtain, you are Dialog and Mobitel is settling the communication cost and giving you a different cost for do the facilitation. So actually Dialog cost is actually 20 rupees, but they are earning a delta amount of number from you for another 10 rupees, called 30 rupees. So at given time, energy grid actually can measure how much energy how much energy importing and exporting from all the houses at any given time. So in the peer-to-peer energy trading, we are doing the same. Instead of giving to the grid facilitator to do this calculation, we are using IoT device to do this calculation by ourselves. So in the same example in the Mobitel and Dialog thing, rather than Dialog is overcharging me 10 rupees, Sausiri, Indranil, and you myself saying, okay, to transact the grid, I will not charge you anything. I will not charge you any grid cost. I will sell as it is without having a grid charge at all. So this is how the energy trading works, and this is the theory of how the contract for different works. So even in the energy industry, it's not really electron. You have a couple of other layers before coming into a bulk pricing level. So let's say if even I say it's like by previous example, I say South Korea will sell like 1 rupee for 1 kilowatt hour. So when we add the grid prices, when we add the energy loss and everything, plus the taxes and so on, it will come around 1 rupee and 60 cents. So the 60 cents is actually for the grid operator, plus all the energy losses and other miscellaneous amounts. So how the energy companies are earning the money, why the energy companies are not loss-making businesses, they are having some X amount of price for energy itself, plus on top of that, there are a couple of layers, and that's their profit basic. So even in the P2P energy trading, the same concept happens. It depends on how the microgrid level or national grid level you are going to work on. Most of the P2P energy trading are not running in the national grid level, mainly because of if lot of energy resources are connected to the main grid, the grid will be unstable. That's why most of the P2P energy trading are running on the microgrid level. But if you have a method to balance this grid, and if you have a proper IoT devices and mechanism to measure this grid manipulation, you can execute it actually. So that's where we did in our countrywide grid in Singapore pilot. We managed to do it, but we have to prepare a report for around 30 pages report for the government saying, okay, it will not happen, because in our pilot we got around 110 people. Out of that 110 people, there are 20 people are the producers. Out of that 20 producers, 18 producers are actually household solar people, and 2 people are coming from CNI, industrial producers. So they have very big solar panel. So the effect for the grid is super negligible when we have a set of 110 people like that. Super negligible. Any other questions?
Any questions from the audience?
Can we extend this session for another 15 to 20 minutes? I don't think I'll be able to finish it within 50 minutes. Or else I can skip the Solidity crash course and go straight away to the smart contract development and show you guys how it's done. But I just want to do the crash course as otherwise you won't understand anything at all. So anyway, let's start.
Yeah,
If there's no
let's move on
question.
to the next.
Yes. So let me. So this is actually the second part of our, I think the screen is visible. So
Yes, it's
can you?
visible.
Okay, sure. So we are going to for the Solidity crash course. Sorry guys, if you feel like it's too much, you can, I will drop this link for here. So the source code for all the smart contract written here are available in this link, in this IEEE-LK repo in my GitHub account. So you don't have to write anything, but maybe you can listen. So what I want to do is I actually want to go to the remix and write the smart contract itself, but hence the time constraint, we'll go like this. So Solidity crash course. So in like every other programming language, we starting from the Hello World program. So this is how we start to write Solidity contract. First, we have to give a license identifier. This came after 0.6 version, saying that, let's say if your smart contract needs some kind of licensing mechanism attached to it, you can actually say, what is your license identifier, whether it's MIT, whether it's open source, whether it's a GPL3 or something, you can just mention it. So let's say if you want to protect your logic or protect your code and protect it by a licensing mechanism, you can actually put it in this comment part. So it's actually not a comment. Without a comment, it will give an kind of a warning for us saying that, okay, for our smart contract, there's no really licensing mechanism attached, but you can still run the smart contract. And we start in the writing the Solidity called pragma keyword, and we are saying the Solidity. And from this one, this this mark, we are saying, okay, the compiler version. So this one, which means for run this smart contract, you can use from 0.8.17 up to the latest compiler to run this program. This is not the best method to write the smart contract, but for demonstration purposes, this is far okay. When you write in a smart contract for the production level, you want to tell exact version, what is the exact version you are going to use. So what we are simply doing is we are removing this symbol here, put either equal or just remove it. So that's what we are doing. Then the contract is starting from the contract keyword, and hello world is a contract name. So if you want to write a smart contract called ABC, I will write contract ABC, then open the curly brackets and close the curly bracket. That's my smart contract. Then I can have this greet variable is I put as a string variable type, and the private is the visibility. If you didn't put any keyword here, by default, all the parameter, all the variables are public. So if he doesn't want to go, if he doesn't want to write the visibility here, it will go public. If you put private, you cannot read this variable at all through the compile. Then we wrote a function called get function, and we are saying return. So hence is the get function and has the return keyword. I can mention, okay, my return type would be a string. So this is string is the return type. And I will say that, okay, please return this variable. So quickly, let me go to the remix. I hope you can see still. And let me. So this is the remix library we are going to use in our practical session, if possible. If not, I will just simply just copy paste, run this smart contract and see. So this is a hello world, and I just copy it, and I press Control S to compile. So you can go here and compile the hello world.sol. So extension of Solidity smart contracts are .sol. When you compile it, and your contract is coming here, the hello world contract. And when you, okay, after that, what we go and do is we are deploying the smart contract in this JavaScript environment. So it's like it's a blockchain running on a browser, for example, for this type. So I put my variable called greet as a private. So you can see here that you can't see there's a variable called greet in this deployed contract. But if you press this get button, you can get in a value saying, okay, hello world. If you remove this private visibility and you save it and compile it and deploy it again, you, okay, with the, is it deployed properly? Compile hello world. So let's put this public here, and let's compile it and deploy. You can see there's a variable called greet because the visibility is public and here. So without the get call, we can see what is the value is. So that's the very simplest hello world smart contract using Solidity. And if you know about the JavaScript, or if you know about the Python, this is super easy way to learn. Then there are a couple of different data types available in Solidity. We call the primitive data types. So first one is a Boolean, which is can store yes, true or false. The uint is actually the integer, which is a positive integers only. So if you declare a variable called uint, you can only record the positive integer. So you stand for unsigned integer, means you can't store any negative values here. If you put int as a variable type, that means you can store negative values as well. And there's another data type called address. Address is actually the wallet address, like this one. It's starting always from 0x, and you have 32 characters here. And you can, that's how you identify people from in the blockchain world, from a wallet address. So these are the main, one of the main four data types, primitive data types. So then based on the variable type, we can have how many number of bytes going to allocate for this exact variable. If you can remember in the presentation, I said if I want to store 100,000 only as a value, and I can exactly say how many bytes it's going to store in my smart contract, because the smart contract is is smart. You have to pay more gas fees if you doesn't manage these bytes proper. Let's say if you want to store only one digit of number, there's no point of having the u in 256, which is 256 bytes variable, just to store one digit. So to store one digit, you should use the smallest version called uint8. Then if you didn't mention any value, uint8 or uint256, the default value is actually for uint is uint256. Means whether you write 256 here or not, if you write only uint, it's getting the uint256 byte space in the memory, in the blockchain itself. So int has the same thing, 8 and 8, 16, 32, 64, 128 up to 256. Based on which number you are going to store, you can choose what type of variable type you want to use. So here you can get the minimum and maximum of int, means how many number of value you can store in the smart contract. And you can see, okay, what is the minimum value you can store and what is the maximum value you can store. So this is the primitive data types in the Solidity. In summary, what you want to understand is there is two ways of recording numbers. One is positive numbers, one is negative numbers. And we have Boolean method to store the data. We have address type of variable to store an address, and so on. Then we are going for the variable, constant, and immutables. So immutable is a way that, constant is a way saying that before we, so when we write in the smart contract, we are saying, okay, this is a constant. That means this value is not going to change, right? Immutable is a constant variable, which value is not going to change, but it's actually declared when we deploy the smart contract. So you can see here, we have a variable type called address, which is a constant called my address. And we have a immutable variable as well called my address too. And there is a method called constructor. Constructor is a function, inbuilt function. When we deploy the smart contract, this is the first set of functions is actually going to execute. So we are saying, okay, my address 2 is the message sender, means who is the person who execute this transaction. My u into is whatever the value I am passing into the constructor value. Then you can do any function, write any function, you can assign something and so on. You can do anything. So we have some state variables here as well. So we have a state variable called string, which is called text equal to hello. So why this is a state variable, why we call it a state variable is state variables are declared outside the function. So you can see this is a function and we write this variable outside the function. We call them state variables. And if you write a function inside, if you write a variable inside the function, we call it local variables. So state variables can access from outside, but local variable only can access through this function only. So that's the difference. Hope it's not too difficult, and we'll move forward. So there's another thing called global variables. See, global variables are actually global variables are actually this block.timestamp. Means when you go to the blockchain, let's say for example, if you want to check Ethereum blockchain, you are going here. So this is the latest block something number. So you can get this timestamp from here, called block timestamp. So what block timestamp is, if let's say if you're going to execute your transaction in this let's say this 0065 block, at what time that block has created, that's the time we are going to get from the block timestamp. So there are some use cases to get that. Let's say if you want to do a lottery kind of thing, you can say from the time I execute the smart contract up to 60 days, you can't withdraw the money. So that's a use case we are usually using for blocks timestamp. Then the message.sender is the address of the caller, address of the smart contract deployer for this contract. We are saying, okay, these are the sender. He will be the owner of the smart contract. So that's the meaning of the message sender. So these are called global variables. So summary: 3 types of variable types: local variables, state variables, and global variables. State variable are writing outside of the function. Local variables are writing inside of the function and call inside only. And there are global variables you can call anywhere from the smart contract. And there are 2 types of way that you can actually write your smart variables. One is the constant, which is you are giving a value straight away. And the other one is immutable, which you are giving a value when you deploy the smart contract. Then we have something called enums. Enum is okay. Enum is common for every programming language. We are saying, okay, let's say we have some action choices. Let's say we have some choices to go left, go right, go straight, system. So for this enum, there is a value assigned from like an array starting from a 0. So this value is action. If you put action choices dot go left, this value is 0. If you put action choices dot go right, that value is 1. So this is enums are important. Let's say if you write in a smart contract and if you have a different levels of different stages of the smart contract and different stages of your flow logic, you can actually use this enum type to tell, okay, this is where you stand. So for example, let's say if you go to the eBay or Amazon.com, you are buying something. First stage is actually you are inserting your personal details. What is your name, email address, telephone number, and so on. So that's the first action. Second action is you are inserting the shipping address. and the billing address, or both at the same time. So that's the second step. So that could be the second action choice. The third one is actually the payment types. That's where you're going to insert the credit card details or debit card details. That's the third step. So likewise, when you write in a smart contract, you can use enums in a different way. So let's say if you have a different status, let's say it's active, inactive, invalid. So you can use the enum. So that's the actual meaning. That's the simplest meaning of how the enums are going to use. So why I'm explaining this is to write our smart contract, we actually need these conditions to know about it. So then favorite arrays. So uh, even up to now, let's say the all the lecturers which I learned programming from, they're saying if you know how to manipulate arrays, you know that programming language very much. So arrays are one of the key requirements and key features of any programming language. So like JavaScript, you are starting a curly bracket and saying, okay, this is an array. So only difference here is you can see, so there are several ways to initialize an array. Here we are saying this public array variable could be a dynamic variable because we didn't give a fixed value. Here we are saying, okay, this array 2 actually has 3 elements, but these 3 elements can be dynamic as well. From array pop method, we can add an array. From the array, the other method, we can actually remove a array value as well. So that's why it's dynamic. So we have fixed size array saying, okay, for this fixed size array, you can actually insert 10 records for this fixed size array. So this is how you are going to say, okay, this is a fixed array. So there are some get function, get array function, and so on. This is for you to try out from that GitHub code, but this is the super simple example of how the arrays are going to define. Then the structs. The structs are important as well. So structs are actually a variable type which you can have custom design variables. So even the Python, you have that. JavaScript also have the struct. So let's say if I want to have a variable called user, inside that variable, I have to record this information. What is the user ID? What is the name? What is the age? And what is the email? So when you load this user struct to get the data, you will get all this information at once. So that's the simplest idea of the struct. So hence we are planning to demonstrate how the P2P energy trading works. You can think about how we're going to use a struct in P2P energy trading platform. So you can save user type, maybe you can save IoT device data and so on. Struct could be used. And there's something called mappings. So mappings is building data structure for assign a value with the key. So you know the key value pairs in JavaScript. So how the solidity method of doing it is actually you are using a mapping keyword and you are saying as a key, I'm going to use integer type key. My value could be the user struct. So to demonstrate this, we'll run this smart contract quickly in the remix one. So structs, let me copy the code, go here, compile it, done it. So I compile the code. That's why I'm getting this green tick here. Then I'm going to this icon, deploy and run the transaction. I will choose what is my a smart contract name called user registration and deploy it here. So when I deployed it, so I'm going to have, I have a function called register user, and I'm getting 3 different values as an input: name, age, and email. So let's say John Doe, age is, let's say, 25, email is john@doe.com. Okay, so I transacted, and from here I can see if you have a green tick, that means okay, it actually recorded in the blockchain. Then I put a mapping here. Okay, sorry, I think I got the wrong one. Sorry, this one. So here what will happen is, I'll show you here. So we didn't give any mapping here. So because this is the previous example, hence we didn't give mapping here. If you add users, to get the users, you have to try out different variable numbers. Let's say if it's 2, it's getting the same value. If it's 4, getting the same values, because you don't have a proper key value pair there. So that's where the mappings are important. So from mapping, you are saying always, okay, there are going to be a map, there's going to be a key value pair. So that's how I want to I want to have this mapping in the smart contract. In peer-to-peer energy trading example, one place where we can use a mapping is, let's say, this A producer giving energy to B consumer, then the mapping could be that producer's ID or the address or anything. So that's where in the peer-to-peer energy trading context, that's how it going to work. So here I deployed the new smart contract having mapping, going to give the same name, John Doe 25, john@doe.com. Then you transact, and it's transacted properly because we are get the green tick. Then here I will put 25 as the key, and you will get nothing here because it says that there's no matching for this key pair value called 25, and there's no name. 80 is email is empty. But if you put 0, sorry, if you put 1, you can get the values of what we put here, John Doe 25, john@doe.com. So, but if you put 2, you will not get anything. Again, let's change these values from John Doe to Jane Doe. Let's say the age is 20, and her email address is jane@doe.com, and transact. So here from the mapping, now because we are when we insert in a user, we are saying okay to increase the user ID by 1. So this is a simple programming stuff which you already know. So if you call the user ID 2, you can see that I'm loading the values of Jane Doe, which is Jane Doe 20 and jane@doe.com. So that's where the mappings are going to interest. And keep in mind, if you have, you can have like up to 3 layers of mapping. Let's say this mapping, instead of user, you can have another mapping inside here. So inside of that mapping, you can have another mapping unit. Up to 3 mapping units you can have. But I think you heard about the grandfather level. So in program menu architecture, anything related to any software development, the best method to have 3 different layers, which is the son, father, grandfather. So if you want to have a great grandfather value in any programming kind of thing. If you want to develop a solution, that means you have to think about your logic again, because more than 3 we are not usually using in the software architecture at all. Just some extra information. So this is how the mapping works. Then the control structures are if then else. So this is how the if commands are writing. So if x equal to 10, return something. If not, else if it's x rather than 20, return 1, else return 2. So the ternary method is like the short form of writing the if then else command is like this, which is common for many languages, including PHP. So it's super straightforward, but this is how the logic, how it's writing. Then how to do the loop. So in Solidity, you can do 2 types of loops. One is for, the other one is while. So in each programming language you learn in, definitely every instructor will say use while loop but in caution, because it can be infinite. So in the smart contract world, we are not really using while any loops at all, because it's super expensive to execute a loop function, control structure basically, because you have to go to the blockchain, read the memory, and you have to reiterate over and over again through the same memory block. Means that you are doing the same execution over and over again. And let's say if you have to pay like 20,000 way, 20,000 gas from way, let's say if you want to run here is 10 times, you have to play 20,000 into 10 times, which is 200,000. So in smart contract worlds, it's possible to run the loops, but not a lot of people are running loops because it's super expensive way to write a smart contract at all. So one way we can actually mitigate these loops to actually use this one, the mappings. Because if you know what is the mapping ID, whether you in string or something, you can go and straight away call the mapping. So no need to send a loop. But for the practice, please go ahead and use the loop function and see how it goes. But production level, if you don't have any other choice at all, use the loops. Loops will be your last resort, basically. Function modifiers means that, so each of these function we can tell, okay, this function can be executed when some certain conditions are met. So what are these certain conditions? We are going to write it inside the modifier function. So modifier also is a function, but we call it, we can call it with the function set and say, okay, you can restrict some of the commands to execute some particular function. So in this example, I have a modifier called only owner, and I said the message sender, whoever the person who is going to execute this function, should be the owner of the smart contract. This is the simplest way explanation of this idea behind this modifier. And you want to have underscore with the semicolon. If you miss the semicolon, it will give an error. And why it's underscore semicolon, that's how you finish a modifier function in the Solidity. Then we are adding this only owner function name at the end of our regular function. And before execute, it will check, okay, is this the set value function is going to execute by the contract owner or not. if it's not going to execute by the contract owner, it will give an error. If it's set by the, if it's going to run by the contract owner himself, it will execute it. So simply let's check what is this modifier is all about. Let me copy and paste the code from my GitHub, and I compile it, and I'm executing this smart contract from this account. So there are 10 to 15 accounts here. I think 10 accounts are here. So I'm going to execute this smart contract from this C4 account. So I deploy it, and now I'm going to set value. Let's say I'm setting a value from 10, and still my account is the C4 account, and I will do the transact button. Then you can see, okay, there's a green tick. That means execute the transaction. Now I'm changing the account to the CB2 account and trying to do the same transaction, to do the transaction for the set value, and it will give me an error saying false transaction mined, but executions are failed because only the owner can call this function. That is the error. So let's put again, let's select the C4 account again. Let's put 20 here, transact again, and you can execute the transaction. Means from these modifier functions, you can tell certain functionalities are going to execute from a certain person only. So that's the meaning of it. So these are the resources for where to learn Solidity language. So first place is actually the official documentation called Solidity Lang. And all my examples are got from a place called soliditybyexample.org. That website, it's a very good website for beginners. It's a very good website for even professional guys also, because their examples are on point. It's very simple, very simple to understand, and you can go. Even up to now, I'm go to Solidity by example. If I forgot about how to execute, how to declare some of the function, how to declare some of the variables, I always go to this Solidity by example website and get the code sample. And there is a YouTube channel called Eat the Blocks. So Eat the Blocks, Damien, his name is Damien. He's one of the super talented smart contract guy I know. Help lot of companies all around the world to write the smart contract. So he's having a channel called Eat the Blocks. It's super good. You can go and learn from him as well. So there's a crash course for 1.5 hours of Solidity. He explained a lot of things. So here I only did like 10 different function, 10 different language features, but there are a lot you can go and learn from the Eat the Blocks. There's another YouTube channel called Depth University. Depth University also very good. So he started his channel is around 2017 something, and started from the scratch. And it has a super good content as well. And there's something called Alchemy University. Alchemy is a blockchain infrastructure provider. So they have a certification, Web3 certification, which is free of charge. You can go and learn Solidity from there as well. So this, and there are other tons of YouTube channels and websites available for learn Solidity, but these are my best 5. Questions, guys? Or if you guys don't have any question, I can go straight away and explain how to build an P2P energy trading platform. I can go through the code with you guys, but we will skip the deployment part because of the time constraint. So first disclaimer, this contract is for demonstration purposes only. It's not intended for use in production environment at all, because there are a lot of loopholes are there. And I will share this code after the session as well. I will upload to the same repo, so you can try it out. And I am not responsible for any damages or losses, because this contract is just for the demonstration purposes only. So I have this prerequisite method as well, but we are going to skip this now because we don't have time. And I'm coming to this diagram. So before we write in any smart contract, before we start writing any logic at all, we are going to think about what exact features, what exact logics we are going to execute. So I got this image from this ResearchGate URL. So what here means is, this is the normal grid, this is the diesel grid, and you are giving energy to this transmission network, and we are going to give you are executing the energy transaction to the distribution network. We can call these two as the grid straight away, and you are giving energy for the houses, consumers, and prosumers. So first thing first, let me try to explain it in a very, very layman terms. So consumer is energy consumer, so the term is a consumer. Prosumer is a person who will consume the energy and export his excess energy, like a rooftop solar user. Then the producer is a person who actually export all the energy which he produces. So there are three types of actors here, called the consumer, producer, and prosumer. And there's another actor called grid operator, or let's say we call brown energy provider or energy retailers. I think energy retail would be the right word. So energy retailer is a person who going to give you brown energy if you don't have enough energy to transact. Let's say, for example, if you have rooftop solar and on that day it's raining and the solar panels really cannot produce any energy at all. So to get the energy from somewhere, you have to get from the brown energy. So there are few actors are there who could be the consumers, producers, prosumers, and retailers. So that's the first part we have to think about. The second part is how to get the readings. So first we have to check how many energy going to consumed by the consumer. So we have to measure the imports of a consumer. Then we have to measure how much energy consumed from the grid for the prosumer, how much energy he has produced, and how much energy he has exported. So then we have another set of reading saying that this prosumer is this given for consumer, how much energy this prosumer has given for this consumer, what is from, let's say, out of 10 export, he's giving 5. And this consumer's input is actually 5 kilowatt hour at that time. So we have to record this reading. So this is the second set of logic you have to understand, which is you have to think about the consumer imports. You have to think about the producer generation and the prosumer export. Then the third one is the matching, which is the question which Indunil actually raised, how to do the matching. So this matching can come inside the smart contract, or it could be come from the outside the smart contract as well. So if you are having a kind of a patent pending matching mechanism, definitely you can have your matching logic written inside the smart contract. So you have to write it outside, but still you can write the logic here in the smart contract, saying, okay, this is how I'm going to do it, and so on. So that's the logic you have to understand before writing any smart contract. So I will explain the smart contract which I already wrote. So give me a minute until I load it. I will just explain the smart contract for the time constraint, because we don't have time, but you will understand that it's the same logic, same set of program which same set of language features we used in the smart solidity crash, nothing else. So this is the peer-to-peer energy trading smart contract, the fully basic one. I will explain what's the meaning of this. So you can, in the solidity crash course, I said that we might need enum to have a record of who are the actors are in our platform. So in here we said that our actors are consumer, producer, prosumer, retail. So here we put the enum called consumer, producer, prosumer, retail. Then we have a struct called who are the users and which user group they are belongs. So let's say user ID is 1, his user group is actually a consumer. User ID 2, he's a producer. User ID 3, he's a prosumer. Likewise, you can have a struct. Then you have going to have another struct to store the IoT data. Because you have to record the user ID, what is the timestamp from the Unix timestamp perspective? What is the import value? What is the export value? What is the generation value? Let's say if it's a consumer, this user type would be 1, timestamp would be a Unix timestamp. You only have the record for the import values only, let's say 1 to any positive number. Export values and generation values are going to be 0. Then I have another struct called energy transfer. So this is where the energy matching should record in the blockchain. So 1 enum set, 3 struct types, and we have 2 mappings. So this is where the mapping I used here. So here I'm getting the user ID as a uint256 and matching into the user. And here the kind of the child and father mapping mechanism. So our previous example, we only had like this. So only this portion only. So mapping is what type of mapping you have and which data you are going to use. But here we are having kind of a son and father figure kind of a mapping thing. So which you can have mapping inside the mapping. If I put into the perspective, forget about this event stuff, because event is the one method when you issue the transaction. If you want to read the what happened in the smart contract, you want to have events. I will cover it actually in my session, but it's an event basic. It's an event triggering from when you execute the transaction. You can call this event type and check what are the values stored in the blockchain. So here I have a function to add users, add IoT data, and add energy transfer. So this is the anatomy of the peer-to-peer energy trading method right in the blockchain itself. And why this is not production grade, because you have to have some sort of energy trading mechanism logic before comes here. So you have to write it. Then there is other stuff saying, okay, here I didn't check that if we have to check whether the producer or prosumer has enough energy to do the trading. If not, you have to trigger an error. So some of the functionalities are yet to write, but this is the basics. So if you think about how we going to write a smart contract for P2P energy trading system, this is the skeleton. First, you add who are the users, what are the IoT data, and how the energy transfer happen. Then you write bunch of functionalities for add users, add IoT data, and add energy transfer to the P2P energy trading. I think that's pretty much of it from my side. I'm sorry that we didn't have time for do this transaction and execute in the Polygon, but let me upload this smart contract into the GitHub repo so you can try it out by yourself. But again, disclaimer, so this is not a production gate smart contract at all. All the functions are public, anybody can execute the transaction. There are no modifiers put into the smart contract itself as well. So you have to think about how to going to execute this in a proper manner. But for a start, this is actually good place where you can think about your analytical mind put into the picture. Yep, that's it from my side. Any questions, guys?
Yeah, any questions from the audience? Oh, there's one question.
How do utilities government welcome the use of public blockchain? Very minimal in the win. I work in my from my previous company, I worked for 4 different blockchain projects related to peer-to-peer energy trading. Thailand is super helpful. Their government is supporting, their regulations are kindly allowing us to do the peer-to-peer energy trading, and they are encouraging it. Malaysia, they are writing their constitution again to allow this to do the peer-to-peer energy trading, because Malaysia is a very large country and they have a lot of excess energy as well, and they are having a different EV plan. So Malaysia wants to have 1 electric vehicle per 1 household, and the government wants to use green energy to charge that vehicle. So that's their vision. So they have a very good plan. Then Indonesia, they kind of had this whole plan to have a green city aside from Jakarta, but it's still under talk. So I don't know when they are going to do it. Then Australia, they are not allowing peer-to-peer energy trading at all in the national grid level. At least they have the microgrid level. In the European countries, UK, they are doing it. Peer-to-peer energy trading is not the exact name they are using it, but the technology is same. They are doing the peer-to-peer energy trading. And Netherlands are doing the peer-to-peer energy trading. France is doing that. France is allowing to do the peer-to-peer trading. Or US, the company called LO3 Energy, that's where the peer-to-peer energy came into the picture. So they did in the microgrid level. So US having some part of it. And maybe you heard about Saudi's newest development called the line. So 400 miles or something. The construction happened in the Saudi called the line. They are planning to do a peer-to-peer energy trading as well. So if you check in their YouTube video about what's their initially to do it, there's a lot of stuff going on in energy. And for the record, I know they are using blockchain technology to do that, because they hired like 5 different blockchain developers from all around the world to get it done. So a lot of projects going on here and there, but regulatory has to change, and the country should have to have a better innovative vision as well. So Sri Lanka, unfortunately, no. We tried it to bring it down to Sri Lanka, but you know how our government works, so I don't want to say it in a recorded information thing. But Sri Lanka is quite far. So, but all the other countries which I mentioned, they are actually taking a lot of steps to change their existing laws and enable the P2P energy trading, especially these vehicle to grid solutions, which is a super innovative way to give excess energy of electric vehicles battery to the grid. Any other question, guys? So meanwhile, you are giving me a question. I'm adding this smart contract in the same repo. You can go and have a look within a minute time. So okay, done. So you have the exercise the smart contract as well for your reference. Go and have a look, try to play it around. So this is exercise.solve. So go and play around. It has all the function and everything. Just remove something and see what is going to give the error. Just try to fix it and so on. Go to that Solidity by example website as well. You can learn a lot from there too. So cool.
Okay, so if there are no questions from the audience, I would like to thank Mr. Anjana for taking your valuable time. Okay, there's one question. Does Electrify use public blockchain?
Yes, we use public blockchain. We use actually Polygon. We started from Ethereum itself. We had before Polygon came to picture, there's something called Ethereum Plasma. Ethereum Plasma main problem was we can only record 32 bytes of records. So we started that platform in 2017. 2018, the Ethereum price went a little bit high, so we need to have a solution where we're going to store records. So imagine if in Singapore the electricity bill is calculated in every 30 minutes, that means one person has 48 records. So if you have 48 records for one person, 100 people has like 4,800 records, which is a lot of records for blockchain perspective because it's super expensive. So we want to have a different mechanism. That's where the platforms like Polygon came into picture, like the side chains and all. So for the questions, we use actually we started with Ethereum, but it was expensive. Then we moved to Polygon. Cool. I think any other question? Why did you go for enterprise blockchain? Main reason is Electrify did Singapore's third largest ICO, initial coin offering, for $30 million. So we can't go for enterprise blockchain because we raise money from the ICO, initial coin offering. So we had to answer for the people who bought the coin by trusting our white paper and so on. So that's why we didn't went with the enterprise blockchain at all. But I know some other companies who are actually using enterprise blockchain to record the data. What we did was a little bit different. We stored the energy transaction in the cloud and we put a hash in the public blockchain. So anybody who wants to verify the data can do that. But all the energy transaction recorded in the blockchain itself, especially the peer-to-peer energy trading, how the mechanism works. So when it's come to blockchain smart contract production deployment, are there any particular common constraint or parameters that we need to focus on primarily? Yes, mainly that who can execute the transaction. That is the first thing. Second thing is your logic should be 110% correct, because you can't do any editing after you deploy the smart contract into the blockchain. So you have to write test cases again and again and again and again. So doesn't matter whichever stupid idea you came with, you just have to write that test cases and try it out before you execute the smart contract in the blockchain. So writing the smart contract is easy actually. By experience, I'm saying. So it's super easy, but writing the test cases is the hard part, because when you think about the logic, there is a certain way of you are thinking about logic in the way. Say, let's say, for example, in the South Korea, the same one question saying that whether it's energy balancing. So I said, no, it's not energy balancing, but it's a proper legit question. You should go as a test case in your smart contract development, saying what will happen if elements in energy managing, like energy balancing kind of thing, happen during the peer-to-peer energy trading. What will happen? So you have to write, you have to think about that test case and use the test cases using JavaScript library called Chai. So when it's come to the production development, we are using hard hat. There's a smart contract development toolkit called hard hat. We are using that one. So you can use, you can write JavaScript test cases using Chai. So that's what you want to think about when you doing the blockchain smart contract development for the production. If you miss something, if you miss one byte, if you miss some variable, there are black hat hackers all over the world, which you can drain all your cryptocurrencies in the smart contract within seconds. So that's why how the hacks are happening. So you have to be so super careful about what you're going to write and who can execute the transactions.
Okay, I think due to the time constraint, we have to stop taking questions. I know it's a very interesting session, but now it's been like close to 3 hours, so I'm very sorry. But I think anyone who is interested can reach Ms. Andana if they have any questions. But for the session, I think thank you very much. I once again thank you for taking up your valuable time. I think it's very late now for you. So thank you very much. It's a very, very insightful and a very timely session. And I can see most of the audience, they were very interested. They had very practical and very encouraging questions. So I hope this session was very fruitful. So thank you once again, Ms. Anjana, for joining, as well as for the people who joined the session. I thank you very much for your time. So we'll meet again in a session like this. So I hope you enjoy the rest of the day, and good night to all of you.
Yeah, thanks. Thank you very much for giving me the opportunity. And I can see Akhil also here. So thanks, Akhil, as well, for providing the opportunity. Thanks, guys.